Slopes of lines, section 3.5. Okay, so this is almost like a coordinate geometry type section here. So dealing with slopes of lines and equations of lines in the coordinate plane. Okay, so today and tomorrow will be a coordinate geometry type sections. If you know how to find slope, today you're going to be doing awesome. Okay, pretty easy for you if you know how to find slope. Alright, slope. Slope a lot of times is defined as the rise over the run, where the rise is the difference in the y values. So if I look over here, I'm given two coordinates. The difference in the y values would be 5 minus a negative 1 equals 6. Difference meaning I'm going to subtract. Whenever I have two negatives next to each other, they get us a positive. Okay. And then the run. The run would be the difference in the x values. Okay, so if I'm given the same coordinates, 3 and negative 1, and then 6 and 5, the run is the difference of my x values. So 6 minus 3 equals 3. Okay. And then, yes, we're talking about slope today. Slope is a measure of the steepness of a line. And if x1, y1, and x2, y2 are any 2 points on the line, the slope of the line, known as m, it's always m, is represented by the equation m equals y2 minus y1 over x2 minus x1. Okay, it's the change in y over the change in x, also denoted as rise over the run. Yes, sir. You can do y1 minus y2 over x1 minus x2 as long as you're consistent and do it the same for both. Does that make sense? And again, slope formula. The slope formula is so important that for you juniors getting ready to NISA test here at the end of the year, they will give you that formula. Okay? We're talking to the Algebra 2 students today. What we're doing today and tomorrow in Algebra 2, almost 1/4 of their NISA test is on that. What we're doing today and tomorrow in geometry, about like 1/8 of your test is on this. So for you juniors, really pay attention to this. And for you other students, pay attention because you'll have to know it for next year or in 2 years. Okay, but again, changing y over the change in x. All right, and then always simplify. Always simplify, please. All right, so what's this look like here? Well, if I'm given a graph, now there will be some problems on the graph, and some students are really like, well, is it that easy? No, it is just that easy if it gives you a graph. Okay, if I want to find the slope of a graph, I simply take the rise over the run. So if I look at the graph here, I'm given two coordinates. I'm given that coordinate there and that coordinate there. So if I'm given just a graph, I simply go rise over run. Okay, rise over run. That's all it is. So I rise up 3 units. I run it 6 units. So my rise over run was 3 over 6, which then I always simplify to 1/2. Now note here, whenever we're talking about slope, always leave it as an improper fraction. Don't put it as a decimal or a mixed number. Leave it as an improper fraction because it is a rise over run. If you do like 3.5 or something like that, it doesn't make sense as rise over run. You might be able to do 3.5 over 1, but then again you have a mixed number. It's just a lot easier to leave it as an improper fraction. Okay, and then here again, this is our slope formula. It's the change in the y values over the change in the x values. And here's an example of how they use all of those values to get that. For those of us who might not have remembered it earlier, now we're starting to recall this from Algebra 1, hopefully. Okay. Good, because it should all be sinking in.
It's not like the opposite of Pythagorean theorem.
No, it's kind of similar to it, really. So number 1 here. I want to find the slope of the line through the following points. Okay? So remember my slope formula, y2 minus y1 over x2 minus x1. One of the biggest mistakes, and one of the few mistakes I ever see students make on slope is, I don't know why, but for some reason, they want to put x's in the numerator. It's always the y's on top, x is down below. Y over x. Y over x. Again, that's about the only mistake I see students make on this. Okay, change in y over the change in x. And if you're a person that needs to visualize, want a problem like this? Well, put, x, y, x, y. Write your coordinates above it, just so you can see. I'm subtracting my y values. I'm subtracting my x values. Because the second mistake is they'll take a y and an x. That won't work. Bless you. Okay. So number 1 here, Troy, I think you were wanting to set it up. How would you set it up if I put it into my slope formula?
5 minus
Ooh, he's going y1 minus y2. Okay. Over?
2 minus 4.
So 5 minus 7 equals what?
Why would you go that?
2 minus 4 gets me what? Well, I have negative 2 over negative 2, which is really just 1. Now, some of you might be like, well, can't I go that way? I can, because I get the same thing. If I were to go the other way, 7 minus 5 over 4 minus 2, well, now I get 2 over 2, which is still a positive 1. Okay, it doesn't matter which way you go, as long as you do the same for the numerator and denominator. I can't take x1 or y1 minus y2 and x2 minus x1. That does not work. You have to do the same coordinates minus the same coordinates. No. Number 2. How would I set up number 2, Max?
4 minus negative 2.
Okay.
Negative 1 minus 3.
Okay, so he went the y1 minus y2, x1 minus x2, and that's okay. Be consistent. 2 negatives there get us a what, Bryce?
Positive.
So 4 plus 2 is?
6.
Negative 1 minus 3 is what?
Negative 4.
So I have 6 over negative 4, which means my slope is what, Bryce? What do you say that was wrong? Do we put mixed numbers? Leave it as improper, so? Negative 3 over 2. Remember, don't put slope as mixed numbers. Don't put it as a decimal either. Leave it as improper fractions. Okay, that way we can see the visual of the rise over the run. Number 3. How would I set up number 3, Tina?
Well,
Either way.
okay, so I went 6 and then 6 minus 2 and then that was plus 2 and then 7
Wait.
minus 1.
What goes on top?
This 7 minus 1
Thank you. 7 minus 1 over.
over 6 minus 2, which would really be 8 because like add.
Okay, the 2 negatives goes positive.
And then you simplify that out and then you get like 6
One thing at a time.
and then you simplify that and you get 3 over 4.
Thanks, Tina. That was a lot of words. Thank you.
Or you could
All right, take a couple seconds here. Try these 4. All right, back to class here. So number 4. What's the slope for number 4? What do you say, Jack?
I had that.
Oh, did you?
What?
What?
1 over 5.
I got 3 over 5, bro.
I believe with 1 over 5, but isn't it negative?
Yeah.
Isn't negative 1/5 as a slope?
Sure.
Number 5. What's my slope for number 5, Jessica? 3 over 5. Nice job. Wait. Negative again.
Yeah.
Negative 3 over 5.
I get negative 5 over 3.
You took your x's on top then. Yeah, you put your x's on top, so wise. Number 6. What do I got for number 6, Boger?
1/3.
1/3. Very good. And number 7. Tom, what'd you have for number 7?
Half.
Number 7? What's it, Peyton? 2. Thank you very much. 8 over 4, which is really just 2. All right, so find slopes. Again, that's kind of a review from Algebra 1. Here comes the geometry parts for us. We're going to start talking now about slopes of parallel and perpendicular lines. Now, we did talk about this last year in algebra. We didn't put a big emphasis on it as it was geometry parts. But parallel lines have the same slope. Okay? So parallel lines, they're lines that have the same slope because they're never going to intersect. So they go in the same slope there, same direction, they're never going to intersect. Perpendicular lines have what would be called opposite reciprocals, which is the same thing. I think last year I used the term, negative reciprocals. Okay? So again, they would be the opposite signs, so one's negative, one's positive, and then they are reciprocal of each other. And a lot of times I say reciprocal, I say refliprical, because why? We just flip the numerator and denominator. So reciprocal is the same thing as like refliprical. Okay? So parallel lines, same slope. Perpendicular lines, negative reciprocal slopes. If they are neither of those, as in they're something like just, 2 over 1 and 4 over 3, Well, those are just intersecting lines then. Okay, if they have just different slopes, then they're just going to be intersecting lines or just neither of those two. Okay. So number 8 here. I want to determine whether the following lines are parallel, perpendicular, or neither. So I have AB and CD. So AB is here. CD is here. I want to find the slope of AB. So I want to find the slope here of AB. Well, to find the slope of AB, I would do 5 minus 1 over 1 minus 2, plugging it into that slope formula, which then gets me a slope of what, Max? So negative 4 over 1. Okay, good. Now I'm going to do the slope of CD. So I have CD here. Set up into my slope formula, negative 2 minus 2 over 5 minus 4. Negative 2 minus 2 is what, Ryan? 5 minus 4 is what, Ryan? So I have negative 4 over 1 and negative 4 over 1. Well, now that tells me they are what type of lines, Drew? Drew? Wow, that's why you don't listen to him. Because the actual answer is what, Kay? Those are parallel. Thanks for paying attention there. Why are they parallel? Because these slopes are the same. Slopes are the same. Number 9, same thing here. I have ST and UV. So here's ST, here's UV. I need to find the slope of ST. So I'm going to say negative 1 minus 2 over 5 minus a negative 2. The slope of ST gets me what, Caitlin? Negative 3 over 7. Nice job. The slope of UV then, negative 4 minus 4 over negative 1 minus 3. The slope of of UV is what, Camden? Oh. Austin, what do you have?
Like negative 8 over negative 4.
Yes. Which that is then comes out to be 2. So I have negative 3/7 and 2. Are those the same slope?
No.
Are they negative reciprocals? No. So they are neither. They are neither parallel nor perpendicular. It's all right.
The last one's perpendicular.
Well, we don't know that yet. Number 10. I have FG and HJ. So FG, I need to find the slope here. So I would do 2 minus 1 over 2 minus 1. My slope for FG is what, Anna? 1 over 1. Nice job. My slope for HJ now, I would do 2 minus 1 over 1 minus 2, which gets me a slope of what, Jersey? What? So negative 1 over 1, same thing, right? Would you agree? So now my slopes are 1 over 1 and negative 1 over 1. And my lines now are what, would you say, Troy? Yeah, those are negative reciprocals of each other. Yeah, because if you flip 1 over 1, you still get 1 over 1. So the negative reciprocals are essentially they're just the opposite signs. All right, try these two. Same idea. Determine whether the lines are parallel, perpendicular, or... All right, number 11. What is the slope of CD, Drew? Jack, what's the slope of CD?
I haven't realized what's missing.
Yo, I got it.
You what?
I messed it up. No,
Mott's?
Negative 4 over 2.
Where does 4 coming from?
He told me it was
Just me.
right.
Troy, what's the slope?
2.
The slope is 2.
Same answer.
When you work it out, you get 4 over 2, or you can say negative 4 over negative 2, but both of them come out to be a slope of 2.
Yeah, I forgot to.
What's the slope of EF then, Trevor?
2.
2. So my 2 lines now are what, Johnny?
They're equal, parallel.
So they parallel.
Good job, Johnny.
Thanks, Nicholas.
Number 12. What is the slope of UV, Troy? What?
3.
Okay. So the slope is 3. What's the slope of XY then? Tyler? No. Not 2 over 0, but it's actually, Troy? Negative 1 over 3. When you work it out, you get, whichever way you work it out, you get 2 over negative 6. As if you work it out, y2 over y1. Which is really negative 1/3. Now my slopes are, what would you say, Caitlin? They are perpendicular. Okay, you have to be able to make sure you subtract and plug them in correctly. Here is your assignment.